As part of the module for notions of data mining and machine learning applied to agriculture, we are going to see a method that's very famous, which has to do with neural networks. These are some auxiliary materials that can be very useful to try and better understand how this information can be used. The first one is a web page where you can train models in the web in a very visual way to try and understand what happens with the model. So I'm going to show a few pages here, but I would recommend you to visit this web page so you can understand better this topic. And there are also some links for additional material for interpretation and how you can interpret this information not only for neural networks but basically for all machine learning. And finally, there's a final link, which is R implementation with neural net. This is for the people who want to follow step by step the implementation in the R software. Now let's see definitions. An artificial neural network is based on a collection of units that are connected, or nodes or neurons that are called artificial neurons. They say that these neurons are inspired um, by the neurons of a biological brain, but the truth is that this is more like mathematical operations, simple mathematical operations. So the name might sound very complex because it tries to remind you of the brains of humans and neurons. But the base node or neurons are basic mathematical operations that allow to create a large complexity when they are joined in the different layers and also with the different functions to represent nonlinear connections. So every connection in between one neuron and another, just like synapses in a biological brain, they can transmit a signal to other neurons. So that's why this is called a network, because they are working in a network that has many connections. And an artificial neuron receives a signal, it processes it, it executes a mathematical operation like multiplication or addition, and they can also send that signal to the other neurons that are connected to them. So they receive the information, they process the information, and then they proceed by sending the signal. This is the graphic representation of a neuron. The neurons have inputs, which are the values of the first layer or the variables that we have, or of a layer, and for each one of the inputs there are different weights. This is a process of multiplication. This is how it's generally done, with multiple regressions in some cases, in other types of analysis with statistics. And generally this is an operation with a matrix. So there's a matrix operation here. The, so it's multiplied by the different weights, everything's added. You can also have a bias, which would be another an additional input to try and maintain the balance or add an additional information. And then after this, that's linear, because it's a multiplication. We also have an activation that usually it's non-linear. So it has an input that's going to map an output that's not linear. So for example, with a nonlinear function, what's very common and that's used here would be ReLU, that's rectify a linear unit. And this name comes from the signal processing reading, but this means that all the values that are below zero are going to stay as zero, and the values that are over zero are going to stay just like they are. So by this, it's how you create non-linearity. And this is one of the biggest reasons of why neural networks are used, because these combinations of weights, of inputs, and activations allow to represent interactions. So this is the strong point of neural networks. With one neuron, you cannot do that much, but when this is complemented with many other neurons in different layers, then there can be a representation of something that's very complex. So why is it a network? Once again, one neuron can't do anything by itself, but it can associate it with other neurons. Generally, the neurons are set in layers, and this is called a layer. And a network usually has an input layer, a hidden layer, and an output layer. But the hidden layer can have between 1 and 1,000. It can have many hidden layers, and the number of hidden layers is also directly related to the capacity of the network to represent things that are more complex. It still requires more care when doing the training. It also requires more time, and that's why there's an optimal amount of layers that can be used in order to have a network that represents information in the proper way. So we're going to find a neuron that's a mathematical operation that have matrices, a nonlinear part, that has an activation function, and everything that's processed in this can be sent to all the others neurons that are in different layers. So this allows for the model to represent all those interactions. And in the end, we can have an output. And another advantage is that you don't have the need to have just one output. You can have, for example, 3 different outputs. And that's very interesting because in the same model, you can do the prediction of different things without the need of having to create a specific model for every single thing. Something else that's very important are the hyperparameters. A hyperparameter is a parameter and a value is established before the learning process begins. So we're talking about machine learning, but this is not all. But the machine cannot learn everything by itself. There are some parameters that I have to set before the training begins. So these are called the hyperparameters. But the values of other parameters are obtained through training. So for example, the different weights that are going to multiply the neurons are obtained by the training itself. But for example, the number of layers, the number of nodes in each layer, and the learning rate are hyperparameters. So I have to define before beginning the training these parameters. And there are other modes to try and automate this and to create an optimization, like a grid search. But in the model itself, it's not optimized. So that has to be defined before. And this is very important because when you think about artificial intelligence, many times there are many times a concept that the machine learns everything by itself. And that's not exactly true. Depending on the level of artificial intelligence and the one that we have today, you need to have a person inputting the information with previous knowledge, trying to fine tune the different parameters to try and reach a model that's efficient.